Next is question number 10.7. It reads, write the equations for the preparation of 1-iodobutane from 3 compounds given here, 1-butanol, 1-chlorobutane and but-1-ene. So here they are asking us to prepare 1-iodobutane. It's a common product that you have to prepare, but our starting material or the reactants are different. So whatever reactions we have done in the chapter haloalkanes and haloarenes, you're going to use that and you're going to apply those reactions here. So before we write down, go into a conclusion, okay, what is going to be the reaction? Let's put down the structures for these one by one as we solve it. So first thing is we need to know what our product is, right? Because the product is common in all three. So it says 1-iodobutane. The compound clearly says it's a butane chain, which is a 4-carbon chain. And on first position, you have iodo group. Okay, so if I'm drawing the structure here, this is going to be my molecule. I have 4 carbons with an iodo here. So this is going to be the product for my compound. So let's try solving one by one here. So the first one is you need to prepare this compound from 1-butanol. When it says 1-butanol, all here is for alcohol, which is starting on the first position on a 4-carbon chain because it says butane here. So let's draw the structure. We have CH3, CH2, CH2, CH2 and OH. So we have a 4-carbon chain and on first position we have OH. From this you need to convert your compound to this. Alright, so that is what you're going to do. So for this you need to check what not reactions you have. So one thing that you've learned is to form an iodine atom on a compound over here. There's only one reaction that you've learned, and which is a name reaction, Finkelstein reaction. Finkelstein reaction. That is the only reaction where it is a halogen exchange method. It is converting chlorine to iodine atom. Right? So this is the reaction. So now we know that if we have a chlorine atom, you can easily convert it to iodine, which is your product, in a process. But do we have chlorine in this compound over here? No, we have alcohol. This is also easy because we have learned the start of the chapter, preparation of haloalkane. Our starting materials were alcohol. And in that we learned around 5-6 preparations. First we learned with respect to PCl3, you used PCl5, you used SOCl2, you used Lucas reagent. So you used all of this, right? So any one of the methods you can use for conversion of an alcohol to a chloro group, and from chloro group to iodo group you can move on to Finkelstein reaction. So this has to be your approach to any reaction when they ask you to convert from one compound to the other compound. Sometimes it may not be a direct equation. Some cases you have to go through 2-3 steps. So always have an approach to go back to backtrack it. You'd look at your product. When you look at your product, you know that okay, you would have had only 1 or 2 reactions. So I'm going to use that. And then I would have multiple reactions for the first step, like you have from alcohol to Cl. Then you can use any one of it. This will come only over proper preparation and proper practice in organic chemistry. Alright, so let's move into the equation now. So we will write CH3, CH2, CH2, CH2OH, which is our first compound, 1-butanol. This is going to be treated with any one of the methods that says preparation of a haloalkane from an alcohol. So I am going to use, say for example, concentrated HCl. I'm going to use Lucas reagent, concentrated HCl and anhydrous ZnCl2. Alright, when I use this, Cl over here, OH over here is going to be replaced with Cl. Alright, so I've got what my product in this case is. Now from here I need to move to preparing iodo group. So I need to get this compound. CH3, CH2, CH2, CH2 and I. What is the difference between both of it? It is only a change in the halogen. So for this I have Finkelstein reaction. That is the only preparation you've learned with iodine in the entire syllabus of haloalkanes and haloarenes. So it's sodium iodide with dry acetone. All these are very important. With dry acetone. The second reaction is a Finkelstein reaction. The first reaction is in the presence of Lucas reagent. So this is going to be your 1-iodobutane and this is 1-butanol. So let's see the second one. In the second one, our compound is different. It says you need to prepare 1-iodobutane from 1-chlorobutane. Alright, so let's move into the second one. The second one is 1-chlorobutane to 1-iodobutane. If you see in both of this, the parent hydrocarbon is the same, butane itself. At the first position only, both the halogens are standing. They are only a difference by one halogen. And since we are preparing an iodo group in the product, you know that this reaction has to be a Finkelstein reaction because you've learned only one reaction where iodine is involved. So here let's draw the structure: CH3, CH2, CH2, CH2 and a Cl, which needs to give CH3, CH2, CH2, CH2 and I. So to move from a Cl to another halogen group, you need to have sodium iodide with dry acetone. So this one is a Finkelstein reaction where the halogen exchange is only happening. So this is Finkelstein with sodium iodide and dry acetone. Now the third one, let's see what the third one is. The third one is from but-1-ene. You need to prepare 1-iodobutane. Now this is an easy one because when I say but-1-ene, this is my structure of but-1-ene. From here, I need to prepare 1-iodobutane. So I have CH2, CH2 and I. Now what is happening over here? You had a double bond here and from that it is becoming a single bond. So what is being added across the double bond? Here this carbon had only one hydrogen, but here this carbon is having two hydrogens. So which means you have added one hydrogen, and on this terminal carbon you did not have any group, but now you have a group. So that means you have added an iodide group. So what is the compound that you are adding across the double bond to get converted to a single bond? You are adding Hi. Now, when you have a double bond and when you have a hydrogen halide, this is going to follow a Markovnikov's rule. But based on Markovnikov's rule, if you see, your major product as per the statement should be 2-iodobutane as per the rule, because the negative part of the adding molecule should be bonded to that carbon that contains least number of hydrogen. But what is the product that has formed here? The iodine has gone to carbon containing more number of hydrogen. So this has to be an anti-Markovnikov's rule. So here, the minute you have an anti-Markovnikov's rule, it is going to be in the presence of hydrogen peroxide. Another name for this is going to be a Karash effect, or we can call this as peroxide effect, because this will happen in the presence of a peroxide. So this is going to be the major product in case of this rule. So here from a double bond, it is breaking to a single bond, and when that happens, on one carbon H is going, the other carbon I goes. And when that happens, this is going to be an addition reaction. This is an addition reaction. So this is your answer to preparation of iodobutane using certain reactants.